de Fuego is detonating at a verified rate of up to 10 explosions per hour as of this week, with incandescent ballistic projectiles being hurled 300 meters above the crater rim, ash columns punching through 4,800 meters above sea level, and shockwaves reverberating across the flanks with enough force to rattle the walls of homes in communities that have no warning system capable of telling them whether the next detonation will be routine or catastrophic. 10 explosions per hour, that is one blast every 6 minutes, without pause, without rest, sustained across days, and the Instituto Nacional de Guatemala's own national monitoring agency, known as INSIVUMEH, has confirmed this activity running continuously through the final weeks of May 2026. If you rely on this channel for science grounded in verified data and explained with honesty, subscribing ensures that none of this reaches you late. This work depends on the audience that values it. Every figure in this script was drawn from official scientific and governmental sources: INSIVUMEH, the Smithsonian Global Volcanism Program, the Volcanic Ash Advisory Center Washington, NASA Applied Sciences Data, CONRED, which is Guatemala's National Coordinator for Disaster Reduction, and peer-reviewed volcanological research. But official sources are not infallible, and neither is the human process of reading them. Before any decision is made, whether personal, professional, or otherwise, verify independently through the official channels. The sources are listed, the data is public. The responsibility to check belongs to all of us, but that is not even the complete picture, because what the instruments at Fuego are recording right now is not simply a volcano being active in the way that volcano enthusiasts photograph from a safe overlook. What is unfolding on the southwestern slopes of this 3,763-meter stratovolcano, rising from the highlands of Chimaltenango and departments in south-central Guatemala, is a system that has been in continuous eruption since 2000 to 24 years of unbroken eruptive activity, and a system that in a single afternoon in June 2018 demonstrated precisely what it is capable of when it transitions from its chronic state to its acute state. The Smithsonian Global Volcanism Program confirms that since 1524 AD, Fuego has produced at least 55 historically documented eruptions. It has been in eruption during 83 out of 502 years of recorded observation. 1 year in every 6, on average, this volcano erupts, and since the year 1900, it has erupted 46 times in 127 years. The system is not inactive. It is accumulating, and the question at this precise moment in late May 2026 is not whether the current sustained explosive phase represents danger. It does. The question that the data forces us to sit with is something older and harder. How much can a volcano signal before silence becomes complicity? The current eruption phase has been generating what volcanologists classify as Strombolian activity, a style of eruption characterized by repeated explosive bursts driven by gas bubbles rising through relatively low viscosity basaltic magma. The name comes from Stromboli, the island volcano off the coast of Sicily that has been erupting more or less continuously for 2,000 years, earning it the title of Lighthouse of the Mediterranean. But Fuego is not Stromboli. Fuego sits on the convergence of 3 tectonic plates: the Cocos Plate, the North American Plate, and the Caribbean Plate, in a zone of subduction where oceanic crust is being driven beneath the continental margin at approximately 7 to 8 centimeters per year, 7 to 8 centimeters. That is, roughly the length of a human finger from the base of the palm to the tip. Every single year, the Cocos Plate descends that distance beneath Guatemala, carrying with it hydrated minerals that release water as they heat and compress, lowering the melting point of the overlying mantle wedge and generating magma that is fundamentally different in its chemistry and its behavior from the gentler volcanic systems of other regions. This is a subduction zone volcano. And subduction zone volcanoes carry within them the potential for violence on a scale that neither the 10 explosions per hour nor the 937-meter ash columns convey on their own. INSIVUMEH's monitoring data through May 2026 has recorded ashfall in named communities consistently across the southwestern and western flanks of the volcano. The villages of Panamish, Morelia, Santa, El Porvenir, Sangre de Cristo, San Pedro Yapacapa, and Pachuta have all appeared in successive monitoring bulletins. Incandescent rockfalls have been descending the ravines. The Volcanic Ash Advisory Center Washington, the VAAC, has issued multiple advisories noting ash clouds reaching flight level 140, which is 14,000 feet above sea level, approximately 4,300 meters, high enough to constitute a serious hazard to aviation across a broad corridor of Central American airspace. Consider what 14,000 feet of ash column means in terms you can hold in your mind. The cruising altitude of a commercial passenger jet on short-haul regional routes is often between 20,000 and 35,000 feet. The ash being ejected by Fuego this week is penetrating to nearly half that altitude. Volcanic ash is not soft, powdery cloud material. It is pulverized glass and rock, microscopic shards with the hardness of obsidian, capable of sandblasting jet-engined turbine blades, contaminating fuel systems, and causing catastrophic engine failure at altitude. The VAAC does not issue advisories as a formality. Every advisory represents a real navigational hazard documented by instruments across a real stretch of airspace, and here is where this account becomes genuinely significant. The community of San Pedro Yapacapas is approximately 8 kilometers northwest of Fuego's crater. According to census data, the municipality of Yapacapa holds a population of close to 35,000 people. The town itself, the concentrated settlement, holds approximately 17,000 people. Imagine a city the size of a small regional market town in any country in the world, built 8 kilometers from the mouth of a volcano that is currently exploding once every 6 minutes. These are farmers, coffee growers, families with children in school, people who wake before sunrise to work land that was laid down by thousands of years of volcanic deposits that made this soil among the most fertile in Central America. The same geology that feeds them is the same geology that threatens them. They know the mountain, they have lived beside it for generations. They wake to its rumbling and they sleep to its glow. And the question they would ask, the question they do ask, is whether the explosion they heard last night was the same as all the explosions before it, or whether this time, this particular morning, something has crossed a threshold that the instruments can detect but the human ear cannot distinguish. The answer to that question requires going backward. It requires going to June 3, 2018. On that Sunday morning, just before midday local time, Fuego produced what the Smithsonian Global Volcanism Program documented as the second major eruptive event of 2018 and the deadliest eruptive episode in the recent history of the volcano. A strong explosion generated an ash plume that rose rapidly to 6 kilometers. Altitude initially drifting west and southwest. Then pyroclastic flows, dense, superheated avalanches of gas, ash, and fragmented rock moving at velocities exceeding 100 kilometers per hour descended simultaneously down multiple drainage ravines, the Sica, Santa Teresa, Ceniza, Mineral, Las Layas, and Honda ravines. They overspilled their usual channels. They did not follow the paths that evacuation planning had assumed. The flow that descended the Las Layas ravine broke containment and swept into communities that had not been designated as primary risk zones. The village of San Miguel Los Lotes was buried, Yel Rodeo was struck, Sangre de Cristo and San Pedro Yapacapa on the western flank received flows that the ravine walls could not hold. Volcanologist David Rothery, speaking to Al Jazeera in the immediate aftermath, stated plainly that the pyroclastic flow was likely the cause of most deaths and that such flows can travel faster than any person or vehicle can outrun them. Temperatures within pyroclastic flows can exceed 700 degrees Celsius. That is not a fire. That is not a landslide. That is a moving column of superheated gas and debris that vaporizes organic material on contact and buries everything beneath meters of ash and consolidated volcanic debris in minutes. The official death toll from the June 3rd eruption rose gradually in the days that followed. Initial reports cited 62 confirmed fatalities. By June 7th, that number had climbed to 109. By August, the confirmed death toll stood at 165, with 260 still missing. The official count as of April 2019 listed 194 confirmed fatalities and 234 people missing and presumed dead. Local communities and villagers stated at the time that more than 2,000 people could still be buried beneath the mud and ash. Research published in 2026 by University College London noted that while official death toll ranges span 200 to 450 confirmed fatalities, local accounts suggest the actual human cost may run into the thousands. The geological record holds the evidence meters of pyroclastic deposit over what were, hours earlier, streets and courtyards and the front steps of homes where people had been standing when they heard the mountain begin to move. This is not a hypothesis. This is documented in the geological record, in the forensic record, in the testimony of rescue workers who described arriving to find entire streets buried so deeply that buildings had disappeared entirely beneath the surface. Guatemala's disaster and forensic agency INSIVUMEH processed remains for months, more than 3,200. People were evacuated in the immediate period. The eruption lasted more than 16 hours before quieting. A second pyroclastic flow descended on June 5th, 2 days later, following the same paths as the first, catching rescue workers in the field who had to flee for their lives from material traveling down drainages they had believed were cooling. This was Guatemala's deadliest volcanic disaster since the eruption of Santa. In 1902, Santa killed thousands of people. The scale of that comparison is not rhetorical. It is the geological and historical baseline against which the current activity in May 2026 must be understood. What the data from late May 2026 shows is a volcano in sustained, intense Strombolian activity that has not abated, the Smithsonian Global Volcanism Program confirmed through its January 2026. Weekly reports that daily explosions at rates of 3 to 10 per hour were generating gas and ash plumes rising as high as 1 kilometers above the summit and drifting as far as 40 kilometers to the northwest, west, and southwest. Incandescent material was being ejected up to 300 meters above the summit. Incandescent block avalanches were descending the western, southwestern, southern, and southeastern flanks, sometimes reaching vegetated areas. By early May 2026, the rate was confirmed at up to 10 explosions per hour, with plumes reaching 937 meters above the vent. By May 10th and 11, INSIVUMEH reported Strombolian explosions classified as weak, moderate, and strong occurring at a rate of 6 to 10 per hour, ash and gas plumes reaching 4,800 meters above sea level, volcanic ballistic projectiles being ejected around the crater area, and fine ashfall reported in communities. On the southwestern and western flanks, On May 16th, a YouTube video documented what was described as a series of powerful eruptions sending incandescent material high above the summit and generating blast waves strong enough to be physically felt. There is a vocabulary that scientists use at this stage that is itself a form of warning. They describe the current state as sustained Strombolian activity within a paroxysmal framework. They note that Strombolian phases at Fuego have historically preceded or transitioned into subplinian events, the kind of eruption that generates pyroclastic flows of the scale documented on June 3, 2018. They note that the drainage systems, the ravines called barrancos in Spanish that channel pyroclastic flows down, Fuego's flanks are the same ravines that carried the flows in 2018. They note that communities remain in proximity to those drainage systems. Scientists choose their language carefully here, and that careful language is itself the warning. There is a second system connected to this story that demands attention, the broader tectonic architecture of Guatemala and the Central American volcanic arc. Fuego sits in a country where three tectonic plates interact in a configuration that simultaneously produces volcanic hazard, seismic hazard, and landslide hazard across a densely populated landscape. The Cocos Plate subducting beneath the Caribbean Plate is the direct driver of Fuego's magmatic supply. But the same subduction process that feeds Fuego also loads the regional fault systems, including the Motagua and Polakic fault zones that run across Guatemala in an east-west orientation, accommodating the lateral motion between the North American and Caribbean plates. Significant seismic events in these fault systems can influence volcanic behavior through dynamic stress, triggering a mechanism whereby seismic waves passing through a volcanic edifice can disturb magma bodies, gas pockets, and hydrothermal systems in ways that may accelerate or amplify eruptive activity. The system is not isolated. It is one expression of a tectonic machine operating across the entire width of Central America, and every component of that machine is connected to every other component by the physics of pressure, stress, and fluid dynamics operating at depths of tens of kilometers beneath the surface. The second connected system is atmospheric. When Fuego's ash columns reach 4,800 meters above sea level, they inject sulfur dioxide and fine particulate matter into the middle troposphere, where prevailing winds distributed across hundreds and sometimes thousands of kilometers. Ash at flight level 140 represents material that has been lofted high enough to interact with weather patterns at regional scale. Fine volcanic ash falling in communities like Panamish, Morelia, and Santa is not merely a nuisance. It contaminates drinking water supplies, it damages crop leaves and root systems, it settles on the corrugated metal roofs of homes, adding weight that in combination with rainfall can cause structural collapse. Volcanic ash, when wet, behaves like wet concrete it does not brush away. Communities downwind of Fuego's current eruptive column have been receiving this material intermittently for months, and the cumulative effect on agricultural productivity, water quality, and public health across the western and southwestern flanks is a slow-motion cost that does not appear in the official eruption bulletins, but is being paid every day by the people who live there. Think about the families in Morelia, a small community on the southwestern flank. The children there wake each morning to a sky that may be clear or may carry the great inge of falling ash. Their parents grow corn and beans on land that has been cultivated by their ancestors for generations. The mountain has always been part of their horizon. Its rumbling is the background sound of their lives in the same way that the sound of traffic is the background sound of a city, but there is a difference that the data makes. Starkly visible, city traffic does not produce pyroclastic flows. City traffic does not transition from routine noise to lethal mass movement event within the span of minutes, with a speed and temperature that makes evacuation impossible once the flow has begun moving. In 2018, people were found in or near their homes, not in the roads, not in the fields, but in their homes because the flows arrived before the warning could reach them. The speed of a pyroclastic flow at 100 kilometers per hour means that from the moment the flow begins at the crater rim, a community 8 kilometers away has approximately 5 minutes before the front arrives. 5 minutes is not enough time to wake a family, dress children, gather anything at all, and reach a location of safety on terrain that includes ravines that channel the flow exactly toward populated areas. CONRED, Guatemala's National Disaster Reduction Agency, maintains alert systems and evacuation protocols around Fuego. INSIVUMEH monitors the volcano continuously with its seismic network and issues daily bulletins. These systems exist because June 3, 2018 demonstrated with devastating clarity what happens in their absence or their inadequacy. The monitoring infrastructure that Guatemala has built around Fuego in the years since 2018 represents real institutional progress, and yet the data also shows that the volcano is now, in late May 2026, operating at the same explosive rates that characterized the weeks and months before the 2018 paroxysm. At 10 explosions per hour, ash at 4,800 meters above sea level, ballistic projectiles ejected around the crater, incandescent rockfalls descending the barrancos. The question is not whether, the question is when. And the honest answer from the volcanological record is that prediction remains beyond current scientific capability. INSIVUMEH can characterize the current state of the system. It can classify the intensity of the explosions as weak, moderate, or strong. It can measure plume heights and track ash dispersal by wind direction. It can detect changes in seismic tremor character that may indicate shifts in the eruptive regime, but it cannot predict with precision the timing of a transition from sustained Strombolian activity to a subplinian paroxysmal event. No monitoring agency on Earth can make that prediction with the precision that the communities on Fuego's flanks would need. The monitoring is in place and detection is possible, but prediction is not. And in the gap between detection and prediction live the 35,000 people of the Apaca municipality, the families of Panamish, the farmers of Morelia, and all the unnamed thousands in the communities that the monitoring bulletins name and then move past. The geological record around Fuego contains evidence of eruptions far larger than anything in the historical period since 1524. Volcanic deposits in the soils and river valleys of this region preserve the signature of prehistoric collapses, massive pyroclastic density currents, and sector failures of the volcanic edifice itself that would dwarf the events of 2018 in their geographic reach and human consequence. This is not speculation, this is preserved. In the physical record of the rock and the sediment, readable by volcanologists who study the stratigraphy of the slopes, the 2018 event, which killed between 194 and potentially thousands of people, was produced by what the Smithsonian classified as a volcanic explosivity index 3 event, a moderately large eruption on a scale that volcanologists consider within the normal operating range for Fuego, a VAAC or VAAC event at this location. Events that this volcano is geologically capable of producing would change the scale of every number in this script by an order of magnitude. Since 1524, Fuego has erupted at least 55 times. That means an average of one significant eruption every 1 years. The current eruptive episode began in 2002. It is now 2026. This is not a periodic eruption in the traditional sense. It is a sustained eruptive state with episodic paroxysmal intensifications. The system has been continuously feeding magma to the surface for 24 years. The question that the long-view data poses is not reassuring. Sustained eruptive systems do not simply wind down smoothly. They fluctuate, they shift, they accumulate stress in ways that the surface expression does not always reveal until the moment of release. The Volcanic Ash Advisory Center Washington, which operates under NOAA and issues aviation safety guidance for the Western Hemisphere, has maintained active advisories for Fuego continuously through this period. These advisories represent a global system of atmospheric monitoring responding to a single mountain in a small country. In Central America, because the atmospheric consequences of what that mountain is doing extend far beyond Guatemala's borders, this is one interconnected system. The ash column above Fuego is made of the same planetary process that built the soil that feeds the people who live in its shadow, and the same planetary process that, on one afternoon in June 2018, demonstrated that the boundary between nurture and catastrophe at this location is measured not in centuries but in minutes. The communities are still there, the mountain is still erupting, the monitoring agencies are still watching, and somewhere on the southwestern flank of Fuego this week, in a house in Panamish or Morelia or Santa, a family is sitting down to a meal in the orange light of late afternoon while 8 kilometers to the southeast, the crater rim glows red and the next explosion is accumulating in the conduit beneath the summit, building toward the moment 6 minutes from now, or 5 or 7, when it will detonate and hurl burning rock into the sky and send another shockwave rolling outward across the slopes, across the fields, through the walls of that house, rattling the plates on the table and reminding everyone within earshot of the fundamental and unresolved fact of their geography. The last confirmed eruption of Fuego began in 2002 and is still continuing as of May 2026, 24 years of unbroken eruptive activity. And the geological record, which does not count in years but in epochs, notes only that this is how Fuego has always behaved, not as a mountain that occasionally wakes, but as a mountain that never truly sleeps, erupting across 83 of the 502 years it has been observed, building and collapsing and rebuilding in cycles of destruction and deposition that predate every nation, every border, every city that has ever been constructed in its shadow, and will continue long after the last instrument that measures it has fallen silent.